Hello friends, myself Vatsalji Patel, Assistant Professor in Civil Engineering Department from Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. Today we are going to discuss about geosynthetics. So let's start with the introduction. Geosynthetics are materials made from various types of polymers used with the geological materials like soil, rock, etc. to enhance, improve or modify the behavior of various civil engineering works. Geosynthetics are available in a wide range of forms and materials, each to suit a slightly different use. These products have a wide range of applications and are currently used in many geotechnical, transportation, hydraulic, and private development applications, including road, airfields, embankments, retaining structures, reservoirs, canals, dams, erosion control, sediment control, landfill liners, landfill covers, mining, and agriculture. So why we will use geosynthetics? We use geosynthetics for the improvement of ground stabilization, pavement for the roads, parking bays, runway or for bearing vehicle loads, heavy duty pavements like ports and harbour, for railway also, for erosion control, for retaining wall and bridge abutment, and most important for the building foundation improvements. So first one is geotextile. Geotextile are permeable fabric which when used in association with the soil have the ability to separate, filter, reinforce, protect or drain. So the characteristics of geotextiles are porous and allow flow of water through it. Most use geosynthetics available in rolls of 5.6 meter wide and 50 to 150 meter long. You can see it in the image. Next, geotextile fabrics comes in two basic form, woven and non-woven. So you can see real life of woven image and microscopic view of it. So let's discuss it. Uniform and regular interweaving of threads or yarn into two direction, regular visible construction pattern. Its function is soil separation, reinforcement, load distribution, filtration and drainage. And it also have high tensile strength and relatively low strain. Second is non-woven, so you can see real life image and microscopic view of it formed by the heat bonding, resin bonding or needle punching. No visible thread pattern. Function is soil separation, stabilization, load distribution but not used for the reinforcement. Also they have high strength and stretch considerably under a load. Next one is geogrids. A geogrid is a geosynthetic material used to reinforce soil and similar materials. Geogrids are commonly used to reinforce retaining wall as well as subbases or subsoils below roads or structure. They have open grid like configuration. For example, they have large apparent between the individual ribs. So you can see this in the image. They have low strain and stretch about 2% under load. Strength is more than other common geotextile. Function is used exclusively for the reinforcement. So we can see that after applying the geogrid or use in the roads, we can see how it transport the load to the soil. So schematic diagram show the load distribution after the use of geogrids. So we can see this soil enforcement geogrids are also used. Also it is used for the grasslands. You can see visible pattern is there in the image. And this is the cross section we show the geogrid and base reinforcement of road section. Next one is geonets. Geonets are also planar products, consist of ribs in two directions and are of the diamond shape. Thickness is larger than that of geogrids, also known as geospacers. Geonets are made up of stacked crisscrossing polymer strands that provide in-plane drainage. Two layers of strands are called biplanar and three layers are called triplanar. You can see it in the image. So biplanar is shown in the image and triplanar is also shown in the image. Application of it. Erosion control. Rib act at a small check dam to slow down the surface runoff, which decreases the erosion potential of water and drainage layer. Water flow along the geonets because of large thickness. Next one is geomembranes. Geomembrane is a very low Permeability, synthetic membrane barrier used to control fluid or gas migration in a structure or system. So you can see the plastic sheet of impervious in the image. Thickness is 0.5 mm to 3 mm approximately, used as a fluid barrier in a designing drainage system, etc., used as damp-proof course in floors, roof, etc. So geomembrane used in agriculture pond, you can see in the image. Application are landfilling lining, canal lining and tunnel lining. So canal lining is also seen in the image and tunnel lining you can see in the image. Next one is geosynthetic clay liner. It is a woven fabric-like material combination of geotextiles and geomembranes used as a barrier for liquid or solid waste, applied below and above geomembrane layers in a landfills, repair mechanism and provide sub-base support. You can see its type in image. Next one is geocells. Geocells are three-dimensional honeycomb-like structure made up of strips of polymer sheet. Its characteristics are similar to the geotextiles or geogrids but have depth, provide both physical contaminant of a depth of soil and transfer the load through it. Also allow water through it, used in the slope with the soft subgrade, used in erosion control in channels. So you can see how geocells are used in erosion control. Next one is geoforms. Geoform is manufactured into large lightweight blocks by polymetric expansion process. They are large but extremely light material which with gas filled shell. It has low density and high strength. Geoform is 1% to 2% the density of soil with equal to the strength. Quick to install and can be installed during any type of weather. If geoform comes in contact with a petroleum solvent, it will immediately turn into a glue type substance, making it unable to support any load. An untreated geoform is a fire hazard, so it is very dangerous to use geoform. So it is mainly not used. You can see geoforms of different shapes in the image. So uses with soil embankments built over soft or weak soil, under road, airfield pavements and railway track systems subjected to excessive freeze-thaw condition, thermal insulation in storage tank and containing cold liquids, separation, lightweight filling, compressible inclusions. Next one is geocomposites. These are combination of two different types of geosynthetic to take advantages of each. This is prepared to exactly all the major properties of the geosynthetics into a single unit with a minimum cost. The various types of geocomposites are geotextile and geonet composites, geotextile and geomembrane, geotextile and geogrid, geomembrane geogrid, and geotextile and polymer core. So you can see all of that in the image. So this table shows the function of geosynthetic material, a type of geosynthetics used and what it provides. So we can see and use the geosynthetics according to it. We saw that the geocomposites provide each and every criteria. Now the geosynthetics area of application. In roads and pavements, subgrade separation and stabilization, base reinforcement, overlay stress absorption and reinforcement. In subsurface drainage, subgrade dewatering, road-based drainage, structural drainage. In erosion and sediment and control, hard armor system, silt fences. In reinforced soil system, embankments over the soft foundation, reinforced step and slope, reinforced soil walls, and in sewage control systems. So use of geosynthetics in earth retention technique, retaining wall. Retaining walls are a structure designed to retain soil or any unnatural soap. So you can see it in the image how geosynthetics are used for the earth retention. So advantages of geosynthetics: cheaper in product cost, transport and installation, can be designed predictably according to requirement. You can design it, can be installed quickly with the flexibility to construct during the short period. Consistence over a wide range of soil, space saving, material quality control, more homogeneous than soil and aggregates, better construction quality control at site, easy material deployment, less environment sensitive, improve performance and extended life, increase safety factor, compatible with the field condition, increase service life of flexible pavement section by a factor of 2.5 to 3.0 for weak subgrade, and CBR value, say California bearing ratio is 2% and by 2.0 to 3.3 for moderate subgrade. So we can see that in the image, real life image is shown of the geocell that it can be used even the steeper slopes. Steel reinforcement are not necessary. So we use geocell in a way that there is no requirement for the steel reinforcement. So you can see the schematic diagram and original image as well. Such earth retention using only geogrid and silt reinforcement is done mostly for the embankments. After a period of 1 to 2 seasons, growth of vegetation take place, making it look like a natural landscape. So you can see that no geogrid is visible and it look like a natural landscape. Also we can see this, it is used for the retaining wall gallery also. So here I end my session. Thank you all of you.